All right. Thank you, everybody, for being here and for taking your time and taking the time out of your precious weekend to just engage in this very interesting community. And thank you to Carlos for driving this and having the idea and moving this forward for us to host the first Pi and AI meetup in Lisbon. So I'm Antonio. I'm head of AI at OutSystems. Essentially, I'm leading the artificial intelligence group at OutSystems that is focused on a breadth of different things related to AI, from product strategy, product management and execution, engineering, and interestingly, research and development as well of the core capabilities that allow us to really use AI and to evangelize AI within the organization. A little bit like Carlos mentioned in the maturity model of AI. That's something we also believe in a lot. So today I'm going to talk to you about how OutSystems has applied AI and done research on AI to improve its own product, which is a software development product, a very particular kind of software development product. How we did it, the challenges, how we approached it, what are the opportunities, things like that. We're also going to talk a little bit, some things are going to be a little bit more technical. I try to not go too technical here. I'm going to mention some things we've been doing in deep learning in particular, and how that can be applied to guide, automate, or validate software developers' work. So this is an exciting emerging area of research and development, and one that we're pushing at OutSystems. I'm not sure if we're going to have time for questions, but if so, I will ask everyone to save them for the end or leave them in the chat. Okay, so starting off, just to give a bit more context, if we look back at human history, we see that the creating tools and using tools were key in our progress through several inventions, through several iterations over time. And software actually became the ultimate tool. It really opened up a lot of innovation, opened up societies, allowed for the great globalization, globalized business and communication we have today, from computers through to the internet. It drove great achievements. And this is why, a few decades ago, and time goes by fast, Mark Andreessen coined the term that software is eating the world. And essentially, we know today that every business is, in one way or another, a software business. Every company is a software company. All the processes, all of the innovation, all of the competitive dynamics you see in the market today, a lot of it is driven by digital systems and computers and the internet and these digital tools, right? And tools to create software also evolved, right? You have increasingly better abstractions, increasingly better programming language, increasingly better tools in cloud computing and Kubernetes and Swift UI, and even low-code development platforms like OutSystems. And in particular, low-code development platforms are one of the biggest improvements in how companies can deliver quality software with great agility. So these platforms, such as OutSystems that you're seeing on the screen, are essentially, you can think of them, if you're not familiar with them, they are full life cycle development platforms, meaning they take care of everything you need to do from a software development standpoint, from the UI to the logic to the data, deployment, continuous integration, continuous delivery, so all batteries included. And you have a very visual and powerful way of programming. So instead of coding using text, we actually have this visual language for you that you see on screen, for you to really customize what your application needs to do or your system needs to do. And from our experience, this makes projects from 6 to 10 times faster from experience with customers. Interestingly, Gartner predicts that by 2024, low-code application development will be responsible for over 65% of application development activity. So it's really something that is taking on the market, and it's really opening up. It's like the next stage of software development tools that is really enabling a lot of companies to become software companies. And one thing that's important also for this talk and for you to realize is that these kinds of platforms, such as OutSystems, is that they open up development to a lot of people without engineering backgrounds, and that we have a lot of stories, great stories of people that change their careers from I don't know, civil engineering or architecture or chemistry, things like that, or even non-scientific, science-based, STEM-based backgrounds. And they can change their careers very successfully, earning more, having more fun. And this is because it lowers the barrier of entry for you to develop great apps. In any case, and taking this to the next level, OutSystems' goal is to make every company what we call a cloud software company. So a cloud software company for us is a company that is able to be at the leading edge of the best practices and capabilities and agilities in delivering software solutions, just like Google, just like Uber, just like Amazon, all of these disruptors that are coming into the market and disrupting incumbents, who have a lot of experience in the business, a lot of expertise, but maybe they have a lot of legacy and they do not have the agility typically, and the skills and the capability and the tools to respond and to really create these very disruptive systems. And so what OutSystems' goal is to allow every company to operate at this top level, and every company becoming a cloud software company. And for us, what that means is that all of our customers should be able to create amazing customer experiences, like the best you've seen, to be extremely agile in responding to business needs and be very quick to respond, and to build their software and the digital platforms with very modern and extensible architectures with no technical debt. But at the basis of all of these things, that to allow every company to really be super proficient in delivering software at scale, is that we want to enable everyone to effectively become a top talent. So everyone to operate at the level of the top level of the market, like the MIT, PhD, Google engineers, but everybody being able to operate effectively at that level in terms of what they output, by creating amazing experiences with extreme agility and with great quality in architecture with no legacy. But currently, what we see is that to become an effective software developer, to become a top talent, it takes a lot of time, and it takes going through several projects and experiences to be able to learn the best practices and to deal with the more complex tasks such as architecture design, refactoring, high performance database tuning, etc. Even when you use a platform such as OutSystems that already lowers the barrier of entry, there's room for us to really take that down even further, we believe. And one thing we also see is that in the field is that projects still benefit a lot from having a seasoned expert to really show the value and the ability of the platform and to achieve stellar results. They are crucial to unblock and teach novices to do code reviews, to analyze the architecture and refactor code, to solve the toughest engineering challenges. But as we know, in everything in life, becoming an expert takes a lot of time, takes you going through a lot of projects, starting building the pattern matching in your mind, starting to understand complexity, so that when you see a new problem, you can take your experience and you can more quickly get to a solution. So that led us to think and ask, what if we could train a machine and package the same expertise gleaned from thousands of projects and data points we see from the data we have, and embed this in the product so that every project and every company can have their own virtual expert out of the box inside the product. So that's the kind of the vision that we set out to achieve. And our vision is precisely that, to make every developer a top talent by creating a virtual expert that we embed in the product and that amplifies every developer's effective skill, powering up everyone and leveling the playing field. So we consider skill to be a sum of autonomy, speed, agility, and output quality. And what we're trying to do is, by infusing this artificial expert, by infusing this AI that learns from all of these projects and code we've seen in automated fashion, we can essentially level up every developer in every skill level, but particularly the novices and the explorers, the people who are still starting, who do not have yet the patterns built into their brain. It's true that lowering the skill is a goal for a lot of different products and for a lot of product managers and engineering teams. So it begs the questions, where exactly can AI help? And so we looked at this, and essentially you could reduce the skill needed And you could amplify the capabilities of people using a product like a software development tool by improving the usability, improving the user experience, providing better documentation, or by improving the language, the programming language and the frameworks, which is essentially, these are essentially the vectors we've seen evolving in the software development market. Like you see, first, you start with very crude programming languages, they evolve, you get better tools, and then you end up with Swift UI, you end up with low-code development platforms, you end up with Kubernetes and AWS and all of those things. So these are improvements in abstractions and in usability. Where AI can be applied is that is a very scalable way to attack complex domains where engineering and creating a specific engineering solution built from the ground up to fix that is expensive or intractable. And when you're developing software, you know that every team does things a little bit different, a little bit custom, and that long tail of differences and corner cases is enough for it to be very hard to create a standard solution for everybody, where you could just go through a wizard or a configuration. You would immediately hit a wall, and you won't really be able to extract value from it. And so we think AI can help by in three different ways. And these three different ways are actually, we think, the three different ways that a technical lead or an expert helps in a team, apart from people management and all of those things and managing stakeholders. So we believe that this AI assistant can help by guiding, for example, by identifying that the developer is stuck, is lost, doesn't know what to do. For example, when they're trying to implement certain pattern, like database synchronization, and providing them with documentation or actual help step and an actual step-by-step tutorial for what they're trying to do. It can automate by automatically, for example, generating this thing they're trying to implement. They're trying to implement a database synchronization or caching mechanism. So maybe we can understand that, we can understand the context, and we're just going to do that for them. Or we can validate. So this is kind of the code review task that tech leads do, which is we want to analyze the code, analyze that implementation that they did, alert developers whether they're doing things in a bad way, and propose better ways to do that to them. And for us, these three pillars are essential in what an AI-assisted development capability should provide. And the market agrees. So Gartner predicts that by 2022, AI, 40% of all projects, software development projects, will have one AI, what they call co-developer or an AI team member working alongside them by 2022. And from our own research, we've seen that the OutSystems developer community considers that AI assistants, over 60% consider AI assistants as extremely or very important for them and for the value they can take from the platform and for the ability they can have. And more interestingly, over 80% of them actually value the validation part of the equation. How can AI help me produce code with better quality, with lower technical depth, with better reliability? This, they consider that to be the kind of the most important factor of it all. And so, taking all of this into account, all of this context and the mission of OutSystems, we created an R&D group inside OutSystems to really push the boundaries of what is possible in this area. And we've done it. So the first thing we did was, we created this research and development team. We started running some pilots. We're starting looking at papers. We're starting looking at the data we had internally. And we always try to work in a very integrated way between research, engineering, and product, so that we can test these capabilities as soon as possible with real users, get feedback, and really push the AI virtual circle, like Carlos was saying. And so the first thing we shipped and we started with was what we generically called AI-assisted development or AI-assisted logic development. And so this is a capability built into our development environment that provides inline next step suggestions in whenever you're programming your logic flow, anywhere in the flow. So it gives you between 1 and 6 suggestions on what you will need next, and with over 90% accuracy. And the more interesting thing and challenging thing is that these suggestions are actually specific to your business logic. This means it's able to suggest things to you that it has never seen before in training data. And there's some, you know, some complexities, technical details here. I'm not going to go over there. But instead of just giving you generic suggestions, or perhaps you want to do an if statement, or you perhaps want to fetch data from a database, it actually can tell you want to fetch data for this for customer by ID, for example, or any specific data entity you have that it has never seen in training. And so it also attempts to autofill all of the node properties and the data fields, and the models are evolving every week. So this first capability was the first one we kind of really worked on and took to product and shipped, and which actually helped us evolve our core technology of neural networks and deep learning. And the kind of deep learning capabilities we're using are like one of the more advanced ones. We use graph neural networks, which are able, you can really apply deep learning not to images, not to tabular data, not to a text, but to a graph, a complex graph that represents the code. And this is kind of one of the things we believe we're going to start seeing become mainstream or in the next couple of years, and we're adopting and successfully using this in production. So this capability is actually used by over a third of our logic users every month. We've evolved the maturity of the AI behind it to go from suggesting just a simple generic next step, like this is an if statement, just fetch data, to be able to be very specific, fully configured next steps. And our vision for the near future, which you can see in this animation, it's not out yet, but it's something that we have in our vision and we're working towards, and we believe we can reach there, is to really understand the patterns and the context and the intent of the user, and completely pre-fill a set of code for what you want here. So here you can see an example where someone wants to implement something to implement a search through a scan barcode. So you have a product listing screen, and you take a picture to a barcode, and it immediately filters the list based on that. And here we're able to infer that that's the intent of the user, and you completely fill the code for them, adapted to the screen and the UI that they have. So this can really accelerate this capability. So since this is an emerging area of application of AI, we really had to start small, start simple, and iterate a lot. And so you can see a huge difference in our artificial expert from the first version that we kind of started testing with users to the version we had at the end of last year. So initially, like I said, we only suggested very high level, vague next steps that people needed to go through and configure each step of the way. And now we can provide very specific, fully configured steps, or mostly configured steps. And so the acceleration starts to get better and better and better. And the most interesting thing is that through the virtuous circle and feedback loop we get, we can get better and better, and the assistant starts getting more specific and more adapted to what you need. So this brings us to the question, how do we actually train an AI tech lead? So this is actually a big scientific and engineering challenge, and we're traversing uncharted waters, really. We're one of the few R&D groups really trying to push the envelope here, together with Microsoft Research in Cambridge, Facebook AI, DeepMind, JetBrains, instead of just adding a few tactical AI applications for show. And that is shown by the techniques and the capabilities that we're using, and the ability we've had of iterating and evolving these capabilities. One of the big challenges is that code is very complex. The domain is very big, and the flexibility is incredible. There's huge variation in how everyone does things. So this makes it way more complex than natural language processing or image recognition. And so it requires us to think differently than classical AI applications. Just to give you an idea, this is a representation done by Gary Tarlow, a researcher in Google Brain, on how AI applied to source code and software development artifacts fits into the general maturity of the different domains. On the x-axis, you can see like the amount of data we have to work with, and on the y-axis, you see what's the maturity and use cases you have really out there to test and to see. And so you can see in the extreme, in the top right-hand corner, you see image, text, and video and speech. It's kind of the things that are more mature and have received the most investment. And software development is really breaking up. It's breaking in, starting to reach the point where it's starting to become really viable and transformative. And that's really where we are. And we are one of the teams pushing this forward, pushing this up and pushing this to the right as well. So one thing I like to do here is give you a sense on the iterative nature of us evolving the brain behind the assistant we shipped, and how the capabilities we've built, because we're using these capabilities of deep learning and AI, allow us to not only attack a very specific domain of giving assistance in that user interface in our tool, to then take that capability, take that brain, and then kind of transport it to a different domain and reuse the learnings it had. So this is a very scalable way of evolving these systems. So we start with the knowledge foundations, and we start from the data always. We also try to look ahead at what we're trying to achieve in the medium term and research the state of the art and assess if we're confident of achieving the results we set out to do. And so we continuously evolve the algorithms and use increasingly more data through dozens of experiments. And so if we see from the beginning where we started from data from about 33 million functions, like you can call it functions, so code, routines, functions, whatever you want to call them, which expand to 21 million micro patterns of code that we have. And the first thing we did was we created a model that was able to predict the next step, very generic next step. So you want to execute an action. An action is like a function. You want to call a function. Then we continued iterating, continued learning, continued evolving the algorithms. And we were able to say, not only you want to call a function, but you actually want to call this function for this kind of data entity. You actually want to create a customer in your database. Continue working on it, and now we can say you want to create a customer with the name John Smith, right? Continue iterating, continue learning, continue researching, and then the brain starts getting a little bit better. And now we can use this capability as well, not only to suggest the next step, but we also can use this to really understand the patterns of code and understand how people implement, for example, a pattern of creating data and synchronizing with your Salesforce system or wherever your ERP is. And this is kind of diverging on it's creating a better capability for analyzing code as well. And then so you can transfer this capability to now implement a different use case completely in your product. So now you can have this capability to analyze code and help in code reviews, for example. Or you can continue evolving the next step suggestions, and then you can reach the vision that I was talking about, where you say, you actually want to do all of this set of code, and I'm going to code all of these steps for you at once. You could also take this capability and apply it to a different kind of data set. You can apply it to UI and data. And we can do this because we use these graph neural networks, this graph deep learning capabilities, which essentially operates over a graph. So as long as you can model your data as a graph, which you can do in our code, and actually any code can be modeled as a graph, we can also model the UI as a graph. And so we can take advantage of the same capabilities and start evolving it to a different domain. And as you go, the brain gets bigger. It can handle different domains. It can handle different things. But the most important thing, the big takeaway, is to be very iterative and create the core capabilities that can evolve over time. And so this is actually a core model for AI applications, which was very popularized by Andrew Ng from Deep Learning AI. So to get better AI and accelerate the AI capabilities and maturity, you really need to ship simple functionality early, integrate it in the product, have users testing it, focus on getting a feedback loop to get the models better and better. And the better these features get, the more users you get, the more data you get. So you get the flywheel going. Just to summarize how we drive all of these capabilities. So our approach and path has followed two technical pillars. One is associated with the use of graph neural networks. So graph deep learning, it's it's a bleeding edge technique and capabilities for doing deep learning. But more interestingly, and I like that Carlos mentioned that machine learning and deep learning is just a part of AI. But we say we use AI because we really do. We don't just use deep learning and machine learning. So we pair this with other techniques in AI, more classical AI, more logic-based AI. One of the techniques we use is called automated reasoning, which is more predictable and is really able to do some very interesting things paired with machine learning. And so we take the power of classical AI with the power of data and machine learning to really create a more capable brain. From a product perspective, we always start from data. We start from foundations. So we start from, okay, what are the foundations that people learn when they're trying to program? Okay, it's how to program logic. So let's start with that. And let's start with the data we have. Let's build from that. And let's build on the AI virtuous circle and focus on creating the feedback loops, even maybe changing the product to maybe collect more data from the users, like explicit feedback, things like that, so that the brain can evolve and grow. So let me just go very quickly, because I'm already over time, on what things we're working on as well on top of that. So one thing we're working on, and you're going to that evolved from this capability I showed in the OutSystems product, is what we call Code DNA. So this is an engine for code understanding and pattern detection and learning. So this can identify what are the common patterns, how people are actually using the product, how are they coding things differently, how are they coding things in a similar way. And we can use this not only to improve the product from an analytics standpoint, but also to support the kinds of capabilities that would be more in line with helping code reviews and helping validate the code. Another area more on the guidance side of it is we're working on understanding how we can provide just-in-time contextual help for novices, giving them orientation whenever they are stuck. So we want to try to detect, we try to understand, okay, this user seems to be lost, doesn't know what to do, doesn't know how to do it. Let me try to give some help. Let me try to understand what it needs. Let me try to give it some help and block them, or perhaps automate the work that they're trying to do. And one other thing we're doing very interestingly together with Carnegie Mellon University and Técnico and Nova here in Portugal is to really think and research, push the boundaries of what we can do from a programming standpoint, but without code. So how can you actually program things that are custom logic or UI or whatever, without actually having to write code, perhaps using natural language or drawing something or giving examples or things like that. So that's something our research team is also working on together with these universities. There are some very interesting things we've been able to validate and prototype and test. And what we're really trying to do is push the boundaries of what is possible in terms of software development, really transforming software development by infusing AI into the process. Not to replace, but to aid, to amplify the developer skill, let them focus more on the more creative tasks, the more value-added tasks in their work. So overall, this was a very kind of compressed view on what we did, why we did it, and where we're going. I hope this was interesting, and I hope this gives you a little bit of more idea on how to implement and use AI and apply AI in the product sense in a very emerging and pushing the boundaries way. Thank you.